Hello and welcome. In this video, we're going to look at how to create a parallel resistance on this breadboard. So at the top here, we have our positive terminal. That's where a red line comes in. And we see that that comes all the way down to this red line here and comes around to the bottom side as well. So our positive terminal, or 9 volts, is on this branch as well. And then we also have this black line, the negative terminal here, and that is going to be connected across here to the bottom, which leads us back into the negative terminal of our battery. So our voltage source and our ground are located on the top and bottom of our breadboard. And since we want to place this into a parallel circuit, we can run from the first of our resistors here directly to our voltage source, right? Because the voltage is shared at the top of each of our resistors. So we know that that is a direct line to voltage, and then the other side of this goes directly to ground. We'll go up to ground here, right? So that gives us a independent branch here. We have voltage coming in through the first resistor and down to ground. We want to do that for each one of these resistors to put them all in parallel. Right? We can do it two different ways. We can technically run the same potential that we had from here directly into this other resistor, or we can just go straight up to where the original potential came from at the top here. So we can do that for each one of these up to ground, right? So now we have a voltage potential coming in through the R2 resistor up to ground. Those two are now in parallel. R1 and R2 are in parallel with each other. If we keep going here, we can do the same thing for R3, voltage on one side, resistance to ground on the other. That gives us our pathway to current there as well. There's 3 resistors in parallel. We can flip this one backwards. We can say that this one goes up to ground here, and then we can go down to the voltage line on this bottom side. Just as long as one side has a positive potential, like this bottom, and one side has a negative potential, like the top, then we'll be able to flow current through there. They can't both be positive or both be negative on either side of the resistor. So let's do that R5 here. R5 can go to ground on the bottom line and voltage on the bottom line there as well. And so we have those negative and positive there. And then our R6 over here does the same thing, ground and voltage. And that gives us our fully parallel circuit. So if we switch over to our schematic view, we'll be able to see that here. We'll trace through this circuit. So this one starts with our positive potential over here. That's our positive terminal of our battery. And we see that the way this schematic is laid out, it put it up here, which means this entire top row is all the positive potential of the battery, and the entire bottom row is all the negative potential of the battery. That's exactly what we wanted for our parallel connection. Then we see that we have R1 connected to the positive terminal. That's our main node across the top here. That's all our positive side. And it's also connected to the bottom side, our negative terminal, all the way across the bottom here. And we see that with each one of our resistors. The R2 goes through there and flows down to the negative. The positive through R4 flows down. R3, R5, and R6 all have a parallel connection because the positive terminal is the only thing on top, and then the negative terminal goes on the bottom side of our resistor. And so that gives us a fully parallel circuit. So let's clear this out. We see that all of these are 1 kilo ohm resistors here. So if we go back over to our schematic, we can actually measure that, and we can calculate it out as well. So we can measure this parallel resistance here by attaching our meter in place of our voltage lines, because we can't measure resistance until we remove our voltage potential. And so we'll click on this voltage line and we'll delete it out, and we'll click on the black line also and delete that out. So now we don't have a voltage or a ground connected, and we can just connect our positive to the positive where we originally had our voltage source attached, and the negative to the negative ground location where we originally had the ground attached. And that gives us the full potential difference. And we're going to be able to send a very small voltage through there using our meter here, and it's going to give us back the resistance of this circuit. So let's simulate that. So 167 is the expected parallel resistance of all of these 1000 ohm resistors. We can calculate that. Let's pull out our Desmos here. We can plug into each piece of this. We can say that we have 6 resistors that all match. And usually we would use the parallel equation where we did the 1 over 1 over 1000 plus 1 over 1000. We can plug all those in, or we can know that since they match, we can just divide them by the number that we have. So since we have 1000 ohm resistors, we'll put 1000 in, and we'll divide that by the number of the exact same parallel resistor that we have, right? And we have 6 1000 ohm resistors, so we can put a 6 on the bottom here, and that's going to give us 166.66. We can round that up to 167, which is exactly what we measured here. All right, let us know if you have any questions.